All right, so in today's video, I'll be sharing with you how to create a parametric drop ceiling using Grasshopper. Now, this is going to be a very basic tutorial, so if you're fairly new at Grasshopper and don't know how to use it, I'll be going over all of the steps so you'll be able to recreate this. So if you get lost or somewhere along the way you have any questions, you can let me know in the comments below. But if you're watching this and I just posted this, you should be able to download the script for free at my website, capettidavid.com. At the end, I'll also show you how to take this and create an AI render from a Rhino render. Now, what's cool about this script is that we can take this line segment and it can be any shape, any form. We can set one curve and apply that design anywhere. So thank you very much for coming by. Hopefully you're excited to learn a little bit more about parametric tools and how to use them for architecture. And with that being said, thank you for being here and let's jump right into it. All right, so the first component we're going to bring in is going to be a rectangle. So let's go here to rectangle. And we're creating a parametric rectangle because once we do this, we should be able to apply any other curve and it should apply it. So now that we have this rectangle and we're routing it through an empty point component or empty curve component, let's give it a size. So I'm giving it an X size and Y size here. Now, the next component is going to be a boundary surface. So boundary surfaces creates a surface relative to that curve. And what's funny is that boundary surfaces is not the same command that you use in Rhino. In Rhino, you actually use planar surface. So I don't know why some of the components have a different name than the command inside of Rhino, but just keep that in mind. Now that we have this surface, now we need to get the midpoint because we're going to subdivide this, and for it to be evenly subdivided, we do want the center point. So I'll go to evaluate surface, reparameterize the input, and then the point is going to be in the middle. So we'll do a quotation mark, which means it's going to bring in a panel, and we'll do 0.5 comma 0.5, which means in the middle of the X and Y. We can always change this. Like if we said 0.4, you'll see that it'll actually be a different location. So I'm just going to undo that, keep this here. Next, we're going to bring in a contour component. This is going to let us subdivide it in the X and Y. Now we can also pick other directions, but I just want to keep it simple in this tutorial because this is going to be more of a beginner tutorial showing you a few tricks that you can get started with. So this surface is going to be the shape. The point is going to be this point. The direction is going to be in the X direction. And the distance, we'll use a slider here to create the spacing. Now, you don't want to start with this low number because it'll create too many and sometimes it could crash your computer. So I will use a slider that starts at 12 and then I go less than 48. So it'll create a limit of 12 to 48. And this way, we can make sure that it doesn't get too small, but we can always increase the spacing this way. Next, we're going to copy this again. But rather than using the X, we'll be using the Y, which means doing the exact same thing, but in the other direction. Now, some of these wires are overlapping, and I do not like that. Sometimes I'll try to get them out of the way, or I'll just hide the input. So wire display hidden. If it gets in the way. So for now, we can see that we can change the spacing this way. We can change the spacing this way. Now we're going to split this surface using these contours. So I'll take the component called surface split, use the surface as the surface input, and the curves that are going to cut it are going to be these. Now notice that when we look at the fragments, this is looking like it's creating different shapes. And the reason why is because this is a grafted set, which means that they are grouped individually. So all we need to do is flatten the input here and hide the original surface. And you'll see that now we have 64 surfaces that are independent that have been cut using these. And so if we change this, let's say to 48, and then this one to 24, now you'll see that we have less surfaces. So basically the split is dependent on the contours and that original surface. So what we need to do now is create this frame. And what we'll do is take this shape, these contours, and we're going to offset them. So let's go to offset. This is going to create that frame. So let's offset it by 1.5. And if we do it in the positive, we'll also do this in the negative. But if we use this as the center line and we offset 1.5 and 1.5, it's actually going to be 3. So this is where I like to double click here on the output of this slider, create a relay, because now the relay is the one that connects to those two, and then use a divide by 2. This will give us a division component with B as 2. And so now we can use 1.5 divided by 2, 0.75. And if we do that to both sides, it'll be 1.5. So we know that this slider is the actual size of the offset. Now we're going to graph, or we're going to loft these two line segments. And this is a grafted set, and this is a grafted set, which is what we want, because we want those two and these two to create a surface independently. Otherwise, if we flatten one, you'll see that it's going to create a surface between all of those, or between these two. So we do want it to be a grafted set, which is what happens naturally when you do this. Now, I'm going to create a relay here. Let's see if it lets me. Notice that this relay goes to 1, 2, and 3 different inputs. So I'll actually unplug here and plug in from here, holding down Shift to this one. So this allows me to take this, copy it, but I'm not going to copy the number. I'm just going to copy this. So I'll select those, slide it down, tap Alt, and you'll see that now we've basically created 2 of them, but this time, instead of offsetting this set of contours, we're going to offset this set of contours. So with these 2, now to bring them together, we're going to use region union. What does that do? It takes this surface and this surface that is overlapping, and it's going to connect them. So I'll plug this in, holding down Shift, I'll hit this one, And notice now that where they overlap, they are now joined. So that's what region union does. It basically booleans union in 2 dimensions. Now we can hide all of this and use boundary surfaces to create the frame. So what's cool about this is now we can change the size of the frame. We can hide some of these contours because they're old, hide the surfaces, and even hide this region part. So on this one, we actually have to flatten the input, and notice that now we have that clean frame. So far, we've brought in a curve, subdivided it, split it, and created the base frame. So notice that we have the outside, but we don't have a frame on the outside. So what we need to do is go back to this curve, and we're going to offset it to the inside. So I'll bring in an offset, this, and I'll copy it over here. Or let's just do it clean with a new one. I'll just go here to offset curve. Notice that by default, the distance is 1, so it's offsetting to the outside. We do want it to offset to the inside, so we will go to a negative component. And now we're going to offset it by the same amount as this one. So what number did we use? We know this is the number. So if we say this is going to be 1.5 inches this way, we can use this number as the distance. Do you see how this number and this wire just overlaps it all the way over here? This is where I will go to wire display, hidden. So we have a clean script. All right, so we've got these two. We're going to create a surface there. So using boundary surfaces, we're going to input the outside and the inside. But notice that here, when we do that, it actually creates two. We either flatten the input here, or we can offset another one by 0. And when you use boundary surfaces, it will work. But with this, now we have this overlap. All we need to do is, rather than using, so the whole script is based off of this curve, the outside one. Well, what if we base it off of the offset that we just did? Now, if we do that, it will now create the entire set here on the inside. If you're having a hard time seeing what I'm doing here, if you're watching this and it's a fairly new video, you'll be able to download the script completely for free so you can see how things plug in. And that's one of the things that I like to do, is make sure that I make the script available for those of you who are here watching it and subscribe, so you can see how things plug in. Now, later on, I do have a large list of scripts that you can take advantage of when you become a member, but I like to make sure that my tutorials are completely for free. I go over all of the steps and I make it available for those of you who are here at the beginning. So now we have this and this. We're going to join VReps. And then take this surface, hold down Shift, and add this one in. So basically we're joining these inside frames with the outside frame. And now we can hide all of this. And if you're like me and you don't like to see these creases, this is where we'll use merge all faces. And it cleans it up. We do have to flatten this input. And notice that we still have that line. Well, that's from this one. So let's go over what we did here. So what we did was create the inside frame, outside frame, joined it, and then got rid of the creases on here. Let's move some of the components, some of the sliders here, so you can see how this gets affected. And then here, let's say 48, maybe it's too much. We'll just do 36. All right, so this is looking good. I'm going to bring this back to 1.5. All right, so we have most of the work done here, because if we take a look at this surface, what we need to do is now extrude it up. So we'll go to an extrude component using the brep, this surface, as the base input. The direction, we need to use a vector to tell it in which direction. So in the Z direction, which means up. And then we'll use a slider, we'll just say of 1.5 here. I'll hide this one and create a custom preview and a color swatch. Just to show you what it looks like with material here. Okay, so now we have the frame. Now the next thing we're going to do is create the panels that go in here. Now they could be acoustic panels, they could be panels that have lights in them, they could be panels that have patterns on them. For now, I'm just showing you the basics. So let's go back to our frames, which are these. They're at the bottom, so we need to take these and move them up. So we'll go to a move component. Now we need to move them up by the same amount as the extrusion. So I'll use this vector in the motion and then use the fragments or those surfaces to move them up to that location. So naturally we can go back to this one, hide it. And these panels, they could either be right up next to each other, or I do like to leave a small gap. So let's offset. It's going to offset to the outside. When you offset a curve, we'll bring in a negative component to make sure that it offsets to the inside. And I repeat a lot of these things because I actually do them a lot, so. So we'll just leave, let's say, like a 1/4 inch gap between, which means a 1/2 inch gap between here, and there's enough bearing capacity here for it to sit on top. Now, these are curves. Even though we plugged in a surface into a curve input for an offset, it will use the boundary as the curve. And now we need to bring it back to a surface using boundary surfaces. And now we can take this and extrude it in the Z direction. Notice here, actually, it's offsetting to the inside. So it might be that causes an issue here. And I think that's because if we look at the surface input, it's going to be based off of this surface, but I think on this one, we can actually use this surface as a surface input. So let's undo that. Let's see here. Oh, okay, I know why. I think that's because this surface also needs to be the surface that for that shape and for this shape. Nope. Okay, let's bring it back. I think I was incorrect on that. So let's leave this at without the offset. I think this will still get the point across here. So we have these panels, and now we're going to take this extrude component with this vector and just copy it over here. Why? Because we need to extrude this as well. Maybe 1.5 is too much, maybe just ½ inch here for the top. I do like to hide the wire for the custom preview and then copy this over here. Plug in the geometry as the input and then use this. Okay. I'll use a geometry component to route this through it and then hit Control G to group it. This way I know this is one of the outputs, and I like to do the same thing with this one because I know this is going to be the panels. So we have the frame, we have the acoustic panels. And so let's apply this to something. So I'll go here to a box. I'll create a box all the way out here like this, make it 15 feet tall. Well, maybe 10 feet tall. I'll type in shell. What shell does is it creates a shell from a solid. So on this one, we'll make 8-inch shell and remove this side and the top. So now we're going to be creating a rectangle here at the top. Let me bring in a scale person. So I have a few different scale persons that I use for my designs here. And all I need to do is drag them in. Let's see if it opened up a new file. Nope. I just need to drag it in here and insert it. And then use this curve that we just created as the curve input. So this is a parametric rectangle. If I use a curve component and I set one curve, the one that is here in Rhino, and I override it, notice that it creates it here. Now let's move around some of the components and you'll see what we can do here. So changing the size. Maybe the configuration just wants to be like narrower like this. Maybe a little bit like this. And it doesn't have to be a shape that is a regular shape. It could be very strange, random shape. Let's just make this one angled like this. Extrude curve up to here. And then I'll move this curve up to here. I'll do shell, 8 inches between this and this. Match the properties here, and then use this as the input. Now notice that obviously we need to offset this by 8 inches to account for the wall. But once we do that, we can set this curve as the input. Why? Because it's using contours, and so the contours will go through anything. So that's the tutorial here. The tutorial was basically to show you how to use a curve. So this one would be set one curve. I like to use caps. This is a parametric rectangle, so you can do this independently. And then here, this is going to be the X. This is going to be the Y, basically the spacing. And the vectors can also be in a different direction. So now here, this is going to be the frame. We'll just call it frame. And then here it's going to be frame depth. And this is going to be panel depth. So, like I said, this will be available completely for free if you're watching this as I post it. If this is a video that's been posted a while ago, you still have the ability to access it. It's just going to be through the subscription. My goal is to share with you all of the steps and share with you the script so you can see how things plug in. And so with this, I think this is going to conclude the tutorial. And I will show you how to take a simple render and bring it into an AI tool that can show you how to turn this from just a basic render to something that you can use to visualize what the space could be in reality. And so let's get into that. For now, I'll save this and let's jump to rendering this into a realistic form. All right, so we have the script here, we have part of the model, and then we have this as a script. So what I'll do is I'll take the custom preview, middle click, and bake it. And to make sure that the script is not overlapping with our geometry here, I'll just go to a new file or even close this one, so we don't have things overlapping. And then I can go here into the Rhino camera so you can see what we'll be doing. First things first is going to be saving this image. So I'm going to go to, or saving this viewport. So let's go here to named view. If we look here under name views, we can go to a plus and call this render 1. Then I'll go here into the rendered mode. Now that we have this here, let's go into selecting these panels at the top. And the way that I do that is I'll go select material name. And since I baked the material from Grasshopper into Rhino, we're going to see two different materials, the frame and the panels. So this is going to be the frame, this is going to be the panels. I'll select those. And I'm not going to be using any other render other than Rhino render. So in here, we have these panels selected. We're going to go to materials. And in here, we'll go to plus emission to make sure that those panels are going to give off some light. So we'll go to assign to objects. And now we can take this and render it. Now to render it, we need to go to the render options. And in here, we're going to see the size. So I'll bring it here to a 2K full final quality. And just leave the defaults for now. And now let's see what it looks like when we render it. So notice here that it's actually a little bit too white, so I'm going to change the color of the person. I'm going to be changing how reflective the material here at the top is. So I'll stop it. I'll use this person here, go to materials, plus plastic, make it a different color so it contrasts a little bit more, and then assign to objects. Now we'll go back up to the frame, and the frame is too reflective here, so it's actually reflecting the light completely. So if we go here to gloss, reflective, change how reflective it is here. All right, let's take a look now. Still pretty reflective. Now the person's looking better. Let's actually change that. So let's go to select material, the frames, which is the custom one. We'll go to plus, metal, assign to objects, and then change it to a rough material, and then change the color to be darker. Now we can also pick here which kind. Let's go to aluminum, maybe a little bit darker. And now let's try the render one more time. That's a lot better. All right, so I'm done with the render here. I think it looks pretty good. The idea here is not to get it to be super complicated or for it to be super detailed. We actually want it to be simple. We want to be able to get the basic forms and shapes. And now let me show you how we can take this render into ReRenderai.com and how we can turn this into something where we can actually visualize this being a space that is being used and has a lot of materials and details. So let's get into that. All right, so this is ReRenderai.com, and let me show you what I use it for. It is a very useful way to create very realistic designs using a base geometry. So let's go back in here. There's different ways to use it. There's render, enhance, coloring, and staging, but we'll be using the render option. Now go to your file and check out and get the render, and let's place it in here. Now in here, we're going to use a style that correlates to what you want it to be. So on this one, it could be a school. So we'll actually use school eco futurism. But if you go under style options, there are they have so many different options that you can use depending on what you're trying to create. So I think this one looks okay. Time of the day, I'll make it midday. I like them to be bright, so I'll just go spring, clear sky. But notice that you can pick so many different options from here. I'll go to cityscape. And then the materials, it's going to be steel. And then in here, we'll call this a, well, since this is going to be at a school, we'll call this a classroom, modern classroom space with furniture and other decorations. When you get down to this part, there's precise, balance, and creative. Precise will make sure that it stays as close as possible to your render. If you go into balanced, it can actually have a little bit more freedom and go a little bit beyond your base geometry. And then creative, it's going to actually go off of the geometry and show you something similar to what you're looking for. So we'll take this one, precise, and now we're going to generate it. So it's going to take maybe a minute, and I'll show you the final result here. So check this out. Just from that image that we plugged in, let's go here to expand, and we can see how you can take something very simple like this and change it into a space that has lighting, that has more geometry, has all the materials, and we can see different options. Now this one kept the person a little bit like a robot. And yes, these panels here at the top could be glass. So this is something. So I'm going to download this one, and then I'm going to go to balanced and see what it creates. All right, so check this out. On this one, it created a few more materials. It added a few more different details. It's not perfect, but it actually shows what the space could look like here. Actually, like this one and this one. I'm going to just change the prompt here to colorful classroom space. All right, so this is the result on that one. So this was before, and this is after. So it had a lot of freedom. It added a lot of colors. It added a lot of designs in here, but the idea was to showcase the ceiling design here. And that's actually kind of cool to be able to have maybe lighting and set right at those intersections. So hopefully you learned a little bit about how you can use AI to enhance your designs, and also learned how to create a parametric drop ceiling with a frame. So thank you very much for being here. Hopefully you enjoyed today's tutorial. I appreciate you coming by, and I hope to see you in the next video.